So Python is programming language, and maybe you should be using it if you're not already. So my goal is not to convince you that Python is better than whatever or anything else. Just it might be the right tool for whatever job you might be doing sometimes. I'm not going to try to teach it to you in any formal way, but just to show you some examples of why Python is, for me at least, fun to use, easy to use, and it doesn't really have a learning curve per se. Like it's executable pseudocode, basically. So I heard Chris tell me once that he likes the idea of being a Python guy, but he doesn't really want to put time into like learning Python, and so you don't really have to. It's kind of partially my goal today. So agenda. What is Python? A couple of reasons why you might want to use it. It's functional and object-oriented, so you can use it a lot of different ways depending on whatever you're trying to do. Some tricks, and at least one example with strings and string mashing. And so I'm going to parse a subversion status output and kind of just play with the data a little bit. So what is Python? Well, I'll give you a second to read the quote here. But really I want to focus on the last sentence, which is that Python combines remarkable power with very pure syntax. You can do a lot of things very densely with Python. It doesn't take a lot of code usually to get something that you can understand and use. So BDFL, and we'll get to what that means. So there should be one, and preferably only one obvious way to do it. Is a quote from the Zen of Python, which is Python Enhancement Proposal number 20, PEP number 20. So the one thing I promised Mark that I put into this presentation is, well, 2 slides from now, but I'll give you a hint. And then, so this is the next chunk of the Zen of Python. Although that way may not be obvious at first unless you're Dutch. And so, for those of you that don't know, the creator of Python, Guido van Rossum, benevolent dictator for life of Python, and he is Dutch. So I fulfill my obligation to Mark. So that's the only thing I promised him I put in here. Okay, beautiful is better than ugly. White space matters. You notice the indentation. If you don't indent, it will not work. You can indent with tabs or spaces as long as you're somewhat consistent. It doesn't particularly matter how. I like to use 4 spaces for indents. Some people like tabs. I think Google uses 2 spaces. I've seen code with 3 spaces. It's yucky. So this is Python code. This is not, well, I mean, it is pseudocode. It's executable pseudocode, aka Python. So define a function named foo, takes 1 argument bar, and then a colon to tell us that, hey, we're going to enter the method body now, and then print the argument unit. And that's all I have on this slide. So explicit is better than implicit. It should be easy to tell what the Python code is doing. So we've got, instead of just an empty block where there's nothing happening, we've got the word pass here. So if bar is false, that's another explicit. It is or is not the same object, rather than equal equal, which could mean some sort of comparison, which is not the same as exactly the same. So this is triple equals in PHP, JavaScript, etc. Or a pointer comparison in C, and or I think equals equals in Java. Yeah. So if bar is false, so is actually the object false? There's one of them. And we can do if bar is not false, which does not mean if bar is true. It just means not false. There's another, so there's true, false, and another built-in that I see, or that I use myself a lot, is none. Some people have differing opinions on whether or not there should be a null. Well, anyway, in Python there's none, and that is, there's exactly one none. It's not zero, it's the object none. So very clearly, not anything else. So here we've got pass as a placeholder. So YPython, there's a lot of libraries out there, a lot of built-in stuff for whatever domain you might need. So here I've defined a function, wait, that takes the argument spam. And if spam is the same as the string duck, then return 5. So duck's wave 5. Okay? And otherwise, we return the input spam. And so I've got kind of some dense code here. And so the output of this filter, lambda, eggs, greater than 3, ham for ham, x range 10, if weight of ham not equal weight of duck. The output of that is 4, 6, 7, 8, 9. And let's go over how we got there. So x range of 10 is a generator. So x range is a generator. So a generator is kind of like the definition in a for loop, where you say, well, for x range at least. So if I'm going to go 0 to 9, then for whatever 0 less than 10, blah. So but the cool part about, and why would you want to do a for loop rather than if 1 and then increase, if 2 and then increase, and so forth. It saves space in the, it saves memory, it saves stack, it loops. So x range is not all that interesting because all it does is return ints, but you can create your own generators where, so it's, you have an entire function body, you can do whatever you want, and you return something on each iteration. So you consume the space of one return and the generator, but you can go forever. So it's, you know, if x range of 10,000 takes up no more space than x range of 10. So, and then here on the next line, you have ham for ham, the next range, if weight of ham not equal weight of duck. So a built-in if filter at the end. So all of the ones in x range 10, if this is not set, if this is satisfied. So all of the ones that don't weigh the same as a duck. So this will give us 1, 2, 3, 4, 6, 7, 8, 9. Or 0, 1, 2, 3, 4, 7, 8, 9. And then back again, I use the built-in filter function with a callable inline function. Lambda is for an anonymous function. So, and that will, so the input to the function is the return from the generator. So as we're going through the generator, we're checking against the lambda and the if statement. So the only thing that gets returned from the generator passes this. The only thing that gets returned from the filter passes the other one also. And we get it for 4, 6, 7, 8, 9. Readability counts. This is one of my favorite features, is real exception handling, where try, except else finally. So why would you want else, for example? Is you isolate the code that specifically you expect may fail from all of the rest of what you're trying to do. So this chunk may break, and then if it does, do something. Otherwise, do what you continue on with the code that you expect will not throw an exception. And then finally, it has a finally block. So no matter what, at the end, clean up, whatever. So multiple inheritance. It exists in Python. So sorry. Right. So if we have this class hamster, and hamster has a function rodent, which returns rodent, and a class elderberry that has a function smell, which returns elderberries. And you are hamster and elderberries. Well, you smell of elderberries and you're rodent also. Notice again the indentation. So white space still matters. Now, why would you want multiple inheritance? Well, so you can get the traits of multiple classes. But so I think HB 5.4 is trying to do this with traits, but I'm not too much of a fan of the way they're doing that, because you have to specify exactly which method you want if there's conflict. And Python does that with method resolution order, so it's kind of, it is, so explicit is better than implicit, but there's explicit rules about how the handling of method resolution. So diamond inheritance is kind of solved and does the same thing every time. So if D inherits from B and B inherits from A and C inherits from A, then if I look for a function on D, I'll look on D, and then I'll look on B, and then I'll look on A. But if D inherits from C, or from B and C, I'll, in that order specifically, then I'll look for that method on D, then B, then C, then A. So this allows you to inject new behaviors into an existing sort of tree just by, so you can subclass two things, and then that throws it into the middle of the method resolution. So, and this is what that looks like in code, which is, so A, B, C. Notice that B and C are kind of exactly the same, but they both call super. So they're both looking to the super object, which is the next object in the method resolution after the argument passed in. And so when I do B, that inherits from, or when I do D, that inherits from B and C, and D.smell, first thing that gets found is B, because that's first in the inheritance, and then C. So B says, look for the next one. And the next one that gets found, because it's closest to D, is C. And then C just finds A, because it inherits from A. Decorators. An easy way to enhance functions with common wrapper functionality. So if I have a function G that takes arguments eggs and ham, and it prints eggs and ham, but I want to enforce that you have to say that I don't want the order that you call eggs and ham to matter. So if you call green with ham equals bar and eggs equals foo in that order, or the other way around, and have it not actually matter, I can wrap it with this decorator, only for args, which takes a function and returns a wrapper function that only has keyword arguments defined. So that'll return us, or so that'll give a type error if I attempt to call it with arguments. Excuse me, positional arguments only. But when I go and call it with keyword arguments, which is the explicit equal sign here, then it works just fine. And we could put more functionality into the wrapper and the only quarks function to give us a better error message rather than a type error that kind of doesn't mean anything unless you know what the code actually looks like. So, but we still only have to put that in the decorator function. Slices. This is another one of my favorites, which is to reverse a string is 6 characters. And so slice is the index. So slices takes basically 3 arguments, up to 3 arguments. So if you give it 1, it's just that index. If you give it 2, separated by a colon, it's the start index to the end index. And then the third one, after another colon, is the step. So here, empty means by default beginning, end, and then so this is beginning, end, step -1. So from the end to the beginning, actually. And so we get the string reversed. Built-in string split, so print every other one, starts at the beginning, print every other one in the negative direction, starts at the end, goes backwards. Couple of notes about Python is that the documentation is usually good. There's easy ways to generate it, and so I like doc test for testing because I get documentation and I get testing all in one. So by just documenting your code with a couple of examples, you get built-in unit tests. And so that's cheap and easy and encourages you to write documentation also. The standard library is kind of big, does most of the things you want from a network-capable programming language. And there are a lot of existing open source projects that add, that are easy to download, and those are located from Python package index, thank you. I always forget what I is. So Python package index is what PyPy is. And AKA,
that version of PyPy. There's
Sure.
the other PyPy.
Well, yes, PyPy with PY is something, I believe it's a Python, yeah, it's a Python implementation of Python, so yeah. And it actually runs faster than the C implementation of Python. The advantage there is that it can introspect, and it actually, like, Python already knows about its own language, so it can cheat, basically. And so it goes faster. And so I'll ask for any questions at this time while I grab a couple of examples for my example.
I wanted to make one comment, just so some people know that some of those examples will only work in Python 2.
Oh, yes, I'm sorry. I have a tendency to write Python 2 code. There is Python 3. I haven't quite learned all of it yet, so I still write code that runs in 2. Oh well. Let's see. Okay, so what I've got here is the output of SVN status, and what I was trying to do on this particular day when I made this was to filter out all of the pets 3 code that was in there, because I wanted to
still requires it to be there.
created. I wanted to patch out things that were not pets 3. So to get into Python, I just want to copy and paste. And so print, and so the same text is in here now, starting the variable A. We good? Okay, so I really just want to find the lines that are in, that have, I want to find specifically the files out of this chunk of text that have pets in it. And to do that, first, does anybody know what mode I just got myself into? Because I lost my hierarchy. Okay, okay. Sorry. Okay, so by default, Python will print the representation of the code, so you notice the \n in here. And so it's just a one big string, and I want to get that to be multiple strings so that I can separate it by lines. And hey, there's a nice split lines. So I'll be so preprint of E gives us a little nicer output, so it's a list of strings now. And I only really am interested in the file names, so let's do a so let's find out how big from here to here is. And to do that, I'll grab the first line. And so index 0, find the position of cool at 8. So using list comprehension, so I'm going to chop off the first chunk of that, so 8 till the end. And then so preprint built-in library, standard library function for preprinting, and all of the junk at the front is now gone. Let's create a set of all of the things in, let's see, with the filter pets in X. So all of these files should have pets in the name. That was not. Okay. And I want to find, so some set arithmetic to find the rest of them, which is all of them, and then so D minus C. Sorry. So what I did there was the set of pets minus the set of everything, which is the empty set. And let's try the other way, which is what I really wanted. So, and then preprint. And we end up with everything that does not have the word pets in, but using set arithmetic rather than inif filter. Any other questions? I can throw in a bunch of little chunks of Python. So let's see. Decent integer math. So arbitrary length integers. So that's 6 to the power 1,000, and it just does it. If I want a string repeated, multiply it by an integer, and it just expands it. Filtering. So if I want all of the things in this list that do not evaluate in a Boolean context to false, I can find that by passing none as the first argument to filter, which is an exception that says exactly that. And I get, well, 1 true and hello. It will evaluate to not false. I take the same list, pass it to the built-in any. Yes, some of them are true. All, nope. Any, until, nope, there's actually nothing in the list. Hey, everything that is in that list is true, except for there's nothing in the list. So, it does make sense. So a default dictionary, giving it a callable to start with. So it'll, anything that's in the dictionary, or so this dictionary will now not fail to have things in it. Oh hey, bars, so it's got now bar foo in it, but always foo in there. Yes. And now that adds it to the dictionary. But if I assign something, it won't work like dictionary. So the usual use case for this would be was a counter. So and you can give it any callable. So a default dict of int would be so it'll call int, so a new int without any arguments will give you 0. So default dict of int. So by default is 0. And so again, explicit better than implicit, plus equals 1 rather than plus plus. And so you can see it starts with 0. 1 there. Okay, so some class. So, okay, 2 more things. Functions are first class objects, so def foo. So foo, so if I do dir of foo, I end up with a whole bunch of stuff. Like food, hot bar, equals. And we can retrieve that later. So you can assign pretty much anything to anything, even though it's a function. And type, so loose typing, basically, or dynamic typing, means we can kind of just mess with it. So I've got a class A, class B, both inherit from object. So let's make a B. But I really don't like my object B. So B dot, let's say, B dot high is hello. Okay, so you can see B has, but B is still a B. I want it to be an A. So B dot, so now B is an A. And it should still have, yep. So you can just change the type of any object if you still feel like it. The usual case there is for when you've got one general type and you actually want to specify down to a subclass. So you polymorphic, except for like in the other direction, I guess. I don't know if there's a good term for that. But that exhausts my list of neat examples, so.
There's 4 else. 4 else.
Oh, 4 else is fun. not what I wanted, but let's try print x. So, okay, so if x 3, for example, what did I do wrong there? X. So I think I'm mixing tabs and spaces in that, yeah. Break, no semicolon. Let's try this again. Okay. X is 3, break, else, x. So we break 0 through 3 and we break, but if we don't break, so what that means is if we didn't break out of the for loop, then do something else also, which is useful when you want it. Because usually you want to do something. So if you hit your break condition, you're already at somewhere you want to be. So you're usually searching for something. And if you don't hit one of those, then you exhaust your for loop, then you might want to do something else. And this gives you a language construct to do that. Questions? Really nothing? All right, so Alex?
Does it let you add things of different types? Like, can you add a string to a number and get the string back with the number in it? In Python? String to an integer?
No, you can't just do string smashing with different types, which is usually a good thing. Because if you're trying to do that, so what there is very nice string formatting just built in. So and it's more powerful than that example. You can do named positionals. And this is the point at which I would go to the docs because I always forget and I just look it up anyway.
Yeah.
Because it tells me exactly what I need to do. But there is that. So
Can you repeat it?
Just change the addition operator on object.
yeah, when you make your own objects, you can define most of the operators on them. So if you really, really want an integer that you can add strings to, well, fine. You can probably make one. But you have to actually try to do that. The last time I made my own basically operator overloading, I was doing an ordered set. So I wanted to keep things in order, but also get all of the set operations. to add two of them and maintain an order.
What's the best way to debug Python?
What is the best way to debug a Python script? For developing and debugging, I would point you to PyDev, which you can get as an Eclipse plugin. It comes with a very nice debugger. You can just run your scripts in debug mode and put breakpoints wherever, but you poke at it pretty well. I think
There's a PDB.
there's PDB too for the command line. I don't know how to use that. I think that's what PyDev uses under the hood anyway.
Very similar to GDB, so I use GDB most of them.
Python used in the site here?
Is Python used in the site here at tagged? As I'm aware, not for actually serving the site, but I know the DBAs use it. I know the analytics loading uses it. I don't know what else.
Argos. Argos.
Argos, which is a screenshot utility. Stig apparently uses Python for something. Build tools. So easy scripting. Okay, that looks like all the questions. Thank you.